the robot operating system with Python to program your robots. This is more about what happens underneath. So if you haven't developed a robotic system before, I'll give you some insight into my experience. This is a project that I did where I developed a robot that children teach how to write so that children with handwriting difficulties can be in the position of a teacher. And essentially, my focus was developing an algorithm where a robot would write badly and then it will improve from children's demonstrations. But in the world of robotics, nothing is that simple. So once you've acquired a robot, the next step is to have some robot drivers. You're going to need motion planning algorithms so that the robot can move around, a tablet for this interaction with the children, a computer vision algorithm that's going to recognize the tablet. And then on a separate computer, you've probably got things like processing voice commands or recognizing emotions from images. And then you're going to want some data logging so that you can review the results of your experiment offline. So in all of this, in a robotic system, has to be running at the same time in parallel. And so what ROS lets you do is split them up into different processes. And so having all of these different functions in different processes, then when they need to talk to each other, they can then send different messages to the other processes. So this is sort of a typical ROS graph that it will have these different nodes, and then they're sending messages between each other. And you might have all of these different processes written in different programming languages because the Android app, for example, you're going to want to use Java, but maybe for the state machine, Python. And so this message passing is what's going to allow them to communicate. So drilling in on that just a little bit, if you've got a camera driver, it's going to be pumping out camera images from the robot. And then maybe there's another process that's going to be taking in those images in order to, for example, detect where the tablet is located in space. And they're going to be communicating via these ROS messages. So ROS as a whole, the project, we at Open Robotics are the stewards of the ROS project, but it's composed of a lot of different projects. So the plumbing that allows things to talk to each other at the low level, but then also introspection or visualization tools. And then there's this whole community of open source roboticists worldwide that provide this ecosystem of different packages that you can sort of drop into your robotic system. So essentially, the project itself is thanks to the community and is quite a big complicated thing that you'll hear lots of talks about. But this one is specifically about the plumbing and what goes on underneath. So beyond this, everything is focused on the plumbing. So in particular about this talk, first of all, we're going to be looking at like the next generation of ROS. This is ROS 2. That's sort of the default whenever I mention it. But also, what about ROS lets these different programs be written in different languages? And this isn't something that's unique to ROS. There are other libraries that try to expose their functionality to users in whatever language the user decides is most appropriate for their application. But something that's different in the world of robotics is that all of these applications need to be running at the same time. And so we'll speak about how they are able to do that different message sharing between running processes. So for processes written in different languages, if we look at the camera driver example, maybe the driver is written in Python, but then that image detector node is written in C++. So underneath what we refer to as client libraries. And essentially when I say client library, I mean anything. It's this part that the user is importing or including in order to get access to the core functionality of ROS, that really plumbing level. So inside the Python library, the Python client library and the C++ client library, there's going to be a lot of similar functionality. The core and the plumbing is going to be the same no matter what language you're in for the most part. And so what we do in ROS 2 is that we have this common client library that sits underneath any client library written in a specific language, and that is where we bundle a lot of the shared functionality. So in there, that is sort of the notion that allows those different processes to talk to each other, but also we have ROS-specific notions of time or console logging that's going to be common no matter what client library you're using. But then there are also going to be some features that are specific to the client library, so that you can have multi-threaded processes in Python. Specifically, you're going to use async IO, and this is something that needs to be written in Python itself. But this separation essentially allows the things that are dependent on the language to just, what needs to be written in the client library has shrunk down, and the rest is just a wrapper around C. To give you an idea of what that wrapping process looks like, this is a very minimalist ROS process. And this function to initialize is what's being provided by the client library. And the things in yellow here are the Python code. And so inside the client library, this is what the function will look like. And essentially, it's just a wrapper around the C extension, which is compiled C that presents itself as a Python module, this RCL-Py implementation. And underneath this is where there's actually C code in the Python client library. And so this C code, essentially, its objective is just to wrap this particular call to the common version of the ROS client library initialization function. And so this, in the C++ client library, essentially it's going to go through the same stack, but on the C++ side. But essentially it hits that same bottom, so you've got that common functionality. So we are in this case wrapping it in it's a really trivial layer, but it doesn't always have to be that way, especially, Python programmers like to program in Python for a reason. And so if I have to put on like my marketing hat, like this would be the billboard that I would make for Python ROS, is that you've got the C features, but it's Pythonic. So as another example, for the ROS version of console logging, this is what it would look like in C, where we've got some functionality to maybe skip the first message that you encounter in a for loop or throttle it at a particular frequency. In C, that looks like a macro call for particular reasons, but in Python, we can represent that as a logging object that then has the keyword args that you can interact with. It's much more Pythonic, and that's by design. So there are some trade-offs in this design, though. Those core features, they're common, but they're written in C, which on the ROS team, like, we are Python developers, and so if we could write everything in Python, we would, but then it wouldn't. C is the most common, the most easily wrappable function by other programming languages. So we purposely will write this in C, which then is going to bring in some C runtime libraries, and you'll have to go up and down these layers, as you saw. But you've got the positive trade-offs, where you've got the efficiency of C, you've got the consistent behavior between the client libraries. That's really the key thing, because we've seen in ROS 1 that it didn't have this design, and you would notice there was some unexpected behaviors. If you fix a bug in one place, then you end up having to go to all of the client libraries to fix the same bug, whereas now you fix it in one spot, it's fixed for all of them. Additionally, we've got a middleware even beneath our client library that we don't have to write that middleware layer in every different language. We write it in C, and it's there for everyone. And it wasn't the case in ROS 1. It was a technical hurdle for people to contribute new client libraries in different languages, because they had to implement the whole stack. Whereas now you've just got that really thin layer, and it pays off, because these are all client libraries that have been contributed by the community in different languages, because they're just implementing this thin wrapper, and then they get access to all of this sort of core functionality. So once we've got nodes that are written in different languages, the question is, how are they going to talk to each other? So we've seen this example. Now we're going to focus on what it is that's happening in between those two processes that will let them talk to each other. And there are a couple of main steps in order for that camera driver to pump out the message. First, it needs an idea of what a message is, and then it's just going to stuff the message and send it out. But we'll look at these in different steps. So for a message definition, in the case of an image, essentially you're going to have the height, width, and the data of the image, and then some metadata. But you'll notice that the information about how this should be presented and how that should be input is very specific. And that is because the community has gone through a standardization process of these messages. so that even though in this case it's a robot camera that's pushing out the image, maybe in another case it would be any sort of webcam, and any sort of, it could be, I don't know, simulated image that's come from a simulator. Anything that is pushing out that standardized image can be consumed by that particular tablet detection process. But similarly, anyone else that is interested in that image will be able to tap into that for whatever purpose. And so this sort of standardization is what allows packages to be sort of interoperable. The question is, well, this isn't really a question, but the next step is how you're going to fill that message. So part of what the client library will provide you is the Python representation of that message, and this is sort of a snippet of the class that you're going to import when you want to interact with that message, and essentially it's just storing that data that we saw, which is used slots so that users can't like piggyback any attributes in there, because if they want new attributes, they need to define a new message type. Following on the same class definition, we've got the getters and setters for these things, and we particularly are interested in having our override, like our custom setter, so that we can ensure that if we've declared something as a uint32, then it better be in the bounds of a uint32. Once you've done that, it's all about sending it to the other messages, to the other processes, and in the case of if we had the case where we knew that there was a Python listener on the other side, then we could probably just send that Python object to them. But you probably know by now that ROS is more generalized, and any of these programming languages might be interested in the same image, and so sending a Python object to them isn't going to be particularly useful. So instead, we have this common language, which again is C. And so even, so that message module for working with the image format is also going to provide functions for you to convert from that Python object into a C representation. And then it's that C representation that is common between the different languages so that they all have this shared understanding of how to interact with the data. So there's another C extension. Each message package doesn't just have that class that I showed you, but it also has a C extension for ensuring that that can convert to and from Python and C. So you probably have guessed by now that we're not writing all of those by hand. To give you an idea of what goes on to get those, the C extensions and also the class that you saw, it's a two-step process. The first is that you're going to pass that message file that you saw, input some particular template data into, we use EmPy because, well, it's just our template instantiator of choice. But if you're curious, be careful to watch the spelling, because otherwise you'll end up with an electromagnetism library. And so, more concrete example of this, you saw what the message definition looks like for an image, and you saw what the output was. And so the template that we're inputting into EmPy, it allows you to put Python code into the template. And so essentially, we're just iterating over the fields that we've passed and stringifying them with an underscore at the front and a comma at the end. And this allows us to create generalized classes for any sort of message input that you could put in. But not just for Python. We actually use this EmPy template processor to also generate the message support for other languages. And as I mentioned, and then also that common C structure, that C representation that they all use to communicate. And then, as I mentioned, there's also the C extension for each of these message packages that's going to get generated automatically as well. So, we use EmPy for a lot of other things in the ROS project. If you haven't heard of it, check it out. But overall, coming back to our example of my robotics experience, now you probably have a better understanding that these are all a lot of different nodes that are going to be written in different languages, and that it's a standardization of these messages that really allows the open source robotics community to have this interoperability, and that you can take things off the shelf and drop them into your system. And so actually 90% of this project I could grab off the shelf and just sort of tweak what I needed to in order to contribute, my core research, work on my research, and then share that back with the community. Specifically for ROS2, we have this common, language of the C message structure that allows them to communicate between each other. But then what really makes ROS2 different to ROS1 is that the thinness of the client libraries and the amount of effort that you need to go to if you decide that you want to write a client library in Rust is so much smaller that it means that we have new client libraries popping up all the time. And this essentially is diversifying the robotics community even more. We're seeing, we're getting into these different applications that we wouldn't have been able to reach if all of those new application spaces had to write top to bottom specifically in that language. So these are the design approaches that we've taken for Rust that have actually benefited our community, and maybe they can apply to your project as well. That's all. So I don't think we have time for Q&A, but the MC has run off, so yes.
I'm new, first time here. You have a GitHub for all this code we can get and then look at it?
Yeah, of course. So if you head to any search that you do for ROS or ROS2, it's going to take you to sort of the main entry point into these things. But it's all totally open source. It's all on GitHub. We'll be happy to share your business cards with you. I'm here with another of the ROS developers from Open Source Robotics Foundation, Mikhail. So we'll be hanging around, happy to answer any questions. Oh, yes.
If you have any more questions, you can ask her, because one of the speakers, Joyce, who was supposed to be here, canceled on last minute. So each of the presenters are going to have 5 minutes for questions and answers.
Okay, so the EmPy library, is there a repository of compiled messages to avoid having to have that dependency in your development environment?
Yeah, so the question was if everyone that wants to use a particular message also has to compile the message themselves and generate these different message formats. So we will bundle those up as part of our packaging process for ROS. The standardized messages will package them out. And if you've come up with a message that didn't exist and you think it ought to exist in the ROS universe, then you can bundle that yourself. And throughout, we actually have a packaging process that allows people to create it in the Linux sense, an apt package for your any ROS module. In this case, it could just be a message module that you're looking to package. And we sort of have tooling that allows you to easily do that so that we can share it with the rest of the community.
Any other questions?